Welcome to Mickey Study Circle channel. In this video, we shall see how to do the computer drafting of the orthographic projection of solids using the Solid Edge software. Coming to the problem statement, a pentagonal prism, 25 sides of base and 60 axis length, rests on HP on one of its edges of the base, which is inclined to VP at 30 degrees. Draw the projection of the prism when the axis is inclined to HP at 40 degrees. So, looking at the problem statement, we can make a set of conclusions. The first one being the type of solid, which is a pentagonal prism, and the pentagon edges measure 25 and also the axis is 60 in length. Coming to the resting condition, it is resting on one of its edges of the base, and this edge on which it is resting is also inclined to VP at an angle of 30 degrees, and also the axis of the prism is inclined to HP at an angle of 40 degrees. So with this data we can understand that coming to the third position, that is the inclination with respect to the VP, is not a beta angle because the edge of the base is inclined to VP and the edge of the base is not going to change its dimension in the second position. So we are going to consider a parameter which has not changed its dimension, and that parameter is considered for the inclination with respect to the VP, and hence it is a non-beta angle problem. Now let us see how the solution for this problem statement can be drafted. Let us begin with drawing the XY line of thickness 0.18 mm. So draw a line of any arbitrary length and then let us annotate the line as X and Y, and also the reference planes as VP and HP. Now let us construct the prism. So while doing the top view of the prism, consider a line of thickness 0.50. Initially, I'm going to construct a pentagon and then we are going to align this as per the required condition. So the edge length is 25, the initial angle is 0, the next edge length is 25 again because it is a regular pentagonal prism, while the angle is 72. Similarly, 25, 72 into 2, 25, 72 into 3. Next, 25 is the edge length and the angle is 72 into 4, or just minus 72. So now the pentagonal prism top view is done. We have to rotate this as per the required condition. So let us select the rotate option, ensure the copy is off, select the midpoint from the interleave sketch. So from this corner, join the midpoint, and now let us rotate it in such a way that the median or the perpendicular bisector that we have considered will be parallel to the XY line. Only then the edge is parallel to the HP and perpendicular to the VP as seen here. So now let us just move this. So this completes the top view of the pentagonal prism. So let us annotate this. So before we annotate, let us mark the center point of the prism. So for that, let us select a line of thickness 0.13 mm. So join the corner to the midpoint of the opposite edge. Similarly, consider one corner and join it to the midpoint of the opposite edge. Similarly, from this corner, join this to the midpoint of the opposite edge. The point of intersection is where the axis is going to originate. So from there, let us draw a projection line from where the axis line will be continued. So now we shall draw the axis line. So select the center line and then the axis measures 60 mm. So this is the axis line that we have constructed. Now let us complete the front view by drawing the projections from the top view. So for that, select a continuous line again and draw the projections from each of the corners of the pentagon. Now the front view can be drawn by selecting a line of thickness 0.50. So from each end point of the projection line, draw the base of the prism, and the height of the prism will be 60 mm. So ensure you are not constructing it as a single line but as a broken line like this, so that will be getting the points to draw the projections from the end point of each of the line that we have considered. So now this completes the front view of the prism. So you can just show that the axis is going to measure 60 mm, and then one of the edges of the prism is measuring 25 mm. So now let us do the annotation. So let us assume that it is resting on one of its corner, A1 and B1. So the top view, it is A, and A1 is inside the square bracket. Similarly, B, B1, followed by C, C1, D, D1, E, E1. Coming to the axis, O is the center point of the top face, while O1 is the center point of the bottom face of the prism. So this is the annotation of the top view. Now let us annotate the front view. So first let us start with the axis. So this is O1 dash followed by O dash. Here for the observer, B1 is visible, so B1 dash, while A1 is not visible, so A1 dash inside the bracket. Similarly, the top face will be B dash inside the bracket A dash. Here it is C1 dash, which is visible to the observer, and E1 dash inside the bracket. And similarly, here it is C dash and E dash inside the bracket. And here we have got the corner B1 dash, which is visible, and here it is D dash, which is the corner D in the top face. So just align all the annotations such that they're not intersected by any of the edge or the projection lines. Okay, so this completes the annotation of both the front and the top view of the pentagon prism resting on one of its edges. Now the next part of the question states that the axis is making an inclination of 40 degrees with respect to the HP. So we will go for the construction of the second position. So before we do that, let us just switch off the midpoint so that the projection lines can be drawn from only the corner points and the midpoint is not confusing us. So now let us just select this front view of the prism. So for time being, let us just delete this axis measurement line, connect all the outer edges, press the control key on the keyboard and then select all the lines along with the annotations. Now let us move the front view. Select the move option, ensure the copy is on. So keeping B1 A1 dash as the reference point, just move this towards the right hand side of the XY line. Now let us tilt the base of the prism at an angle of 90 minus the angle of inclination of the axis, which is 40 degrees. So the angle is 90 minus 40. So the base inclination is 50 degrees. So to have sufficient place to complete the third position, we shall just move this again towards the left side a bit. Okay. So with this, we complete the front view of the second condition. So you can just measure the inclination angle, which is 40 degrees as given in the problem statement. So now let us draw the projection lines and complete the top view of the second condition. That is, the axis is inclined to the HP at an angle of 40 degrees. So draw the projection lines from all the corners and also the axis. So these are the projection lines which will help us to generate the top face of the prism. Now let us draw the projection lines from the bottom face of the prism. Let us draw the horizontal projections. So B1 and B, A1 and A1 to the extreme projections. Next, C is here while E is here. Next, from D through O, let us try to intersect the projections till the point O. Using the trim option, let us just trim the projection lines which is not required for our constructions. So O1 dash will end here, so this is not required. While C1 dash will connect till here, the point D1 will end here. Here also, the point D1 is going to end here. The point D1 and D. So these are the set of projection lines that are used to draw the top view of the pentagonal prism. So now for the observer, the edge B1 dash and A1 dash is the farthest points. So now let us select the line option. Select a line of thickness 0.50. So let us start from the top face of the prism. So the observer is looking from this direction. So this is B and this is A. And then, so from AB to the corner C, back to the corner D, D to E, and E to A. This is the top face of the prism. Now, so you can just see that there is a mistake here. So always ensure the lines are getting connected to the end points of the projection lines. Okay. So now we shall go for the construction of the bottom face. So the bottom face will start from the point of intersections. So here it is a hidden line. So go for the broken lines or the hidden line. So from the point A1 to the point B1, and next the point C1 is here. Similarly from A1 to E1 also it will be a broken line. So next other lines will be the outer edges which are visible. So from E1 let us connect it to D1 and D1 to C1. So this is the projections of the top and the bottom faces of the prism. Now let us connect the parallel edges, that is from D to D1, C1 to C, and then from E1 to E. So this will be again a dotted line. So what we can do is we can just use the trim option so that we can trim this line and connect it directly by a dotted line. So here I'll be trimming this line also so that I'll be having this as a separate point that is identified. So the only reason was I'll be getting a distinctive point of O1 and O. So now let us connect the bottom edges by the hidden lines, that is A to A1. Similarly B1 to B. Use the trim option to trim the okay, use the extend to next option. So this completes the top view of the pentagonal prism when the axis is inclined to the HP at an angle of 40 degrees. Let us annotate this. So this is the corner A, corner B, corner C, corner D, and corner E. While this is corner A1 and this is the corner B1, this is the corner C1, followed by the corner E1 and then the corner D1. This is the axis point O1 and this is the axis point O. So just use the trim option and show the axis line here. So go for the line option, select the cutting line or the center line of thickness 0.13. So from D to O, you can just show a part of the axis line, that is O1 to O. So this completes the second position. So now with respect to the VP, the inclined parameter is the edge, that is a1 b1 on which it is resting. So since a1 b1 has not changed its dimension even in the second position, so we are going to consider it to be a non-beta angle problem. So now let us see how to complete with the third projection. So draw a line in such a way that it is making some offset with the xy line so that the outer face is not going to cross the xy line. So from this point, let us draw a line which is inclined at an angle of minus 30 degrees. So you can just see that if I extend this line, it will be equal to 30 degrees. So use the angle between and measure the angle. So it is 30 degrees. So on this 30-degree line, I have to incline the resting edge, that is A1, B1. So for that, let us select the top view of the pentagon prism from the second position. So in the previous videos, I've shown you how to make it a rigid set. So here I'm not showing it because the video length increases. So I've selected all the edges. Now I'm going to select the annotations. So I've made this a rigid set earlier. C1 and O. Select the axis point also. So now I've selected the entire prism. Now I'll be selecting the move option, ensure the copy is on. So let me select the edge A1, B1, or just select the point A1 and place it on the 30-degree line. Now go for the rotate option, ensure the copy is off. A1 is the first point of rotation, B1 is the second point of rotation. So still you can see that it is crossing the XY line. So for this reason, I'll select the move option and then just move this a bit downwards. Okay. So now this completes the third condition, which states that the resting edge is inclined to the vertical plane at an angle of 30 degrees. That is A1, B1 is inclined to the vertical plane at an angle of 30 degrees. So now I'll complete the front view by drawing the vertical and the horizontal projection lines. So first let me draw the set of horizontal projection lines from the top face. So from the point D dash, C dash, E dash, from the axis O, and then B dash and A dash. Now I'll draw the similar projections from A, from corner B, it is on the same line, while corner C will be here. So just enter the angle as 90 degrees so that the projection line is straight. Next from D, intersect with the horizontal projection of D. Similarly from E, intersect that with the projection of E. And the point O is here, and let us intersect this here. So let us use the trim option to trim the projection lines which is not required for any of the constructions. Okay, so now we have got this. So we are going to consider the farthest point. So the observer is here. So for him, the bottom face of the prism is completely visible, and the farthest corner point is the corner E. So from the corner E, all the edges will be the hidden lines. So for that, let us select the line option of thickness 0.50. So let us start from this edge, that is A, B, and then the corner C is here, then to the corner D, then coming back to the corner E, and then E to A. So we'll first complete the faces and then make the hidden lines. So now let us go for the line option again. Draw the projection lines to complete the bottom face of the pentagonal prism. So from the axis point, draw a parallel line to the reference line. C1, E1, draw a line parallel. D1, draw a line parallel. So the points A1, B1 shall lie on the XY line only. So now let us draw the vertical projections. So A1 is here. So B1 is here. You have to use the zoom options or else they will appear as if they're overlapping on each other projection lines. Next from the corner, C1. Okay, so I have to extend this a bit. So enter the angle as 90 degrees, then make a connection. Then D1 is here. So the angle is not exactly 90. So there is still some gap. So what I can do is use the extend to next option. And then similarly from the point E1, let us connect it here. While the point O1 is here, use the extend to next and then connect O1 to O1 projection lines. Okay. So now from the corner E, everything should be invisible. So E to D and E to A shall be the hidden lines. Now let us complete the bottom face of the prism. So now select the line option of thickness 0.50 mm. So we'll start with the point A1 and then the point B1, which is there on the XY line, and then to the point C1, which is here, then to the point D1, and next to the point E1 and back to A1. So now select the line option again and select the continuous line. So now let us try to connect the edges. That is E1, okay, that is from D1 to D. This is C1 to C, while this is from E. This is the corner E1, so E1 to E, and this is from B1 to B. So the next edge will be the hidden edge. So from A1 to A. So with this, we complete the front view of the pentagonal prism. Now let us just annotate this. So this is the bottom face and this is the top face, right? So this is B dash, while this is A dash. This is C dash. This is D dash, and this is E dash. The point O dash is here, followed by E1 dash, and then A1 dash, and this is the point B1 dash. This is C1 dash. This is the corner D1 dash, while this is O1 dash. So now let us draw the axis line connecting O1 and O in the front view. So this is O1 to O. So this is the axis line. So ensure the axis line will have a thickness of 0.13. So this is the axis line O1 dash to O dash. This is the corner B1 dash. So we have completed the problem with this. So that is, it is resting on the corner A1 B1, and the same edge, that is A1 B1, is inclined to the VP at an angle of 30 degrees, and the axis is inclined at an angle of 40 degrees. So with this we complete the problem. So you can just indicate the direction of the projection lines using the leader option. So this can be shown for all the projection lines. So with this, we complete the drafting of the solution for the given problem statement. Thank you all for watching.